Good. Hello, everybody. We are going live. We are super live. Welcome to DoK Community Session number 98. That's right, folks. In just over a year, we're going to reach 100 live streams, meetups that we've done as a community. The 100th will be next week on Thursday. You can bet that we'll be doing something special. There'll be some live music. We'll have some prizes we'll be giving away. Also going to do a quiz just to see how much you really know about the DoK ecosystem, about some of the different speakers that we've had, the different topics that we've covered, and different things that kind of make us unique. Today's speaker comes from a company, Civo, that's also one of our sponsors. So big shout out to Civo. I was telling Dinesh before we got started that Civo just got a super rock solid dream team of rock stars. We had the pleasure of having Alex Jones with us when he actually wasn't at Civo, but now is. Definitely a big fan of his. Big shout out to Anais, who's in the audience as well. I got to meet David in KubeCon, I believe, so big shout out to him too. Kunal Kushwaha, of course, Siam. Anyway, Ricky, we can go on and on, all the wonderful, Sophia, all the wonderful folks that work at Civo. But today we're going to be talking about something that has been a part and parcel of the data on Kubernetes community since we got started. This issue of storage. People will tell you it's delicate. People will tell you it's dangerous. If you've ever moved house, you know that moving stuff can get complicated. Things can get broken, things can get lost. So when companies are in this situation and need to think about moving their storage from one provider, one vendor to another, how are they going to do that? And that's why the wonderful title that Dinesh got for today, it's not me, it's you. I think it's a very nice way of putting it. Dinesh, welcome to the Data on Kubernetes community. Wonderful to have you with us. Can you just tell us about who you are and how you got it, how you found yourself in a position where you'd even have to be considering these difficulties, challenges of moving one, storage from one place to another?
Yeah, hi. So Dinesh, I'm Director of Innovation at Civo, one of the members of the team that are there. And yeah, we've got, as I said, a great team. And actually, all of the code that I'm going to be demoing today is none of my code. This is all David's code. So I'm going to pretend to take all of the credit, but in reality, if it goes wrong, I know where I'm pointing the finger.
So that's also the title. It's not me, it's you. So we know it's going to
exactly,
you.
Exactly. But no, I mean, kind of various reasons of why we got into this situation. Obviously, some are contractual. That we came up for a renewal basically, and it gave us an opportunity to look around and see what else was out there. So that's the position that we're in. But the great thing about building Civo as cloud native kind of from the ground up is that everything has been designed to be replaceable in the nicest way possible. So, it's the same thing with Kubernetes. If something breaks, you almost just delete it and it comes up again on a different node. That idea with data as well, of you delete your PVC and you can have some sort of process that either restores it from backup or, as we're going to go through today, allows you to migrate from one PVC to another. And during that process, if you just change the storage class, great, you've now gone from one vendor to another vendor. Or even things like, some vendors have replication. So if you've got a volume that is replicated twice and you need to go down to a single replica, this same process can be applied. So it's not only for moving vendors, it's what we're using it for, but it's a great tool that we have now in our arsenal.
Very, very good. That being said, folks, as usual, and for the Civo folks as well, you can put your questions in the YouTube chat and we'll get to them accordingly. I expect nothing but, very difficult armor-piercing questions from David and Anais, as well as anybody else from the Civo team. But as usual, if you got questions, just let us know. Also, when Dinesh switches to show some code, if you can't see for whatever reason, you'd like him to zoom in, just leave a comment here and we'll follow up accordingly. So if you want to share your screen, go for it.
Yeah. So I promise it won't be death by slides. So hopefully that has come up and you've got a full screen of my slides now.
Yeah, perfect.
Excellent. So very, very quickly, you can get to know me a bit. I've been doing this sort of thing for 15 years in the shared hosting industry. It's a very interesting space to work with because you're talking to customers from all scales of things, and they've all got the most important thing ever and the most important application ever that's got to be online. And I've got experience working from first line, where you get the most difficult questions, all the way up to third line, where you've got the difficult problems. And then various other things, developer, system architect, doing DevOps work, you name it, I've probably done it in the hosting industry. So Civo, you probably have heard of us, but we're a new cloud native public cloud provider, really focused on Kubernetes at the moment. So We offer you the ability to run Kubernetes clusters. We aim to get every cluster launched within 90 seconds from you clicking the button to it being ready for you to use. We've got a load of Terraform providers, we've got a CLI, we've got a lovely GUI as well. And over the past 10 months, we've launched 3 regions, which I will, we might talk about a bit. And just as Civo in general, we're looking to add more racks, add more regions, and just grow. Kind of covered this already a little bit about why we're migrating, but we came up for contract renewal and we just looked at the market again. The last time we looked at storage providers was about 2 years ago when we kicked off the project and our new sort of Civo Stack initiative. And we chose the best vendor at the time. But the new partner that we're going to move towards and move over to, they honestly, the performance wasn't great 2 years ago, but the great thing about this space is people move on, move forward, and they're now using some new technology. It looks really, really quick. It's really, really exciting. And it's fully open source as well. So if there are issues, we can find it in the code. If there are features missing, it allows us to develop it and push it out there. So we're really excited. It's probably a pain in the ass for us for the next few months to do this migration, but other than that, I think it's a really good opportunity for us going forward. Kind of want to cover off what our current hardware architecture is because it underlines what we're trying to do. So we have in a single one of our regions, probably about 30 to 35 what we call compute nodes. So each of the compute nodes has 2 NVMe drives. We've got 2 boot disks, CPU, RAM, and then we run containers on these compute nodes. We are a heavy user of the KubeVirt project. So those containers are actually VMs themselves. And when you launch a tenant cluster, we launch containers containing K3's instances effectively, and then you consume the VMs on top of that. Each of the containers VMs have a root disk, which all of the data is stored on for like the operating system and K3s on it, and they are stored on the NVMe drives. So our current architecture is all of the NVMe drives are allocated to a single vendor. But what we need to do is move over so that this architecture supports both vendors at the same time, allows us to do the migration, and then we re-provision again to move over to a single vendor. So if we were working in the cloud, this would probably be a really, really easy solution because we'd spin up another 35 compute nodes with the second vendor. And then as we migrate data, we just turn the old ones off. In the land of physical servers, that's more challenging because we can't just spin up a rack and then delete it again afterwards. It becomes a very expensive proposition. So the first architecture that we can consider is probably doing something very, very similar of if we allocate, say, half of our architecture and the compute nodes themselves to vendor 1 and half of them to vendor 2, we can go down this route and do a migration. But it comes into kind of problems of how do we get to this stage? And that is just a problem of replication, really. We would delete one of the nodes from the cluster, one of the compute nodes, and then the way that the storage architecture works currently is the data would get replicated over to the existing compute nodes that are still in there. Then we can do some migration and then rinse and repeat, and it's a little slow process to do that. We might go down this route. It's probably not been decided yet, but the other option is that we have 2 NVMEs in each of the servers. So we can actually just remove one of the NVMEs and partition our supercluster in this way. We're not decided yet, but this is these are 2 options that we could go down. They both have their pros and their cons. Probably less data moving around with this one before we do our migration, but it's more challenging to do because you're kind of splitting concerns on a single compute node. Either way, whichever one we go down, we've got a migration process to do. So what we need to do at a very high level is shut down the VM that's running, migrate that data, update the object, start it up, and then remove the old data. Very, very simple. And thankfully, due to some of the tools out there with KubeVirt, it does seem very simple. So what I want to do is I'll switch over to a terminal now.
Quick question on that before you get over to the terminal.
Yeah.
When we're looking at this migration process, who are the stakeholders that are going to be involved in that?
So it's the SRE team. They're the ones that are going to be actually running it. And from a sort of end user customer point of view, there's probably not a whole lot of involvement because we offer Kubernetes. Everyone is deploying clustered services. So as long as we take down one of the nodes in the cluster at a time, it's almost seamless to the end user because their workload itself will move over to the other node in the cluster. Once that then starts up and is migrated, we then switch over to the next one. So, it's an internal process as far as I can see, rather than having to tell customers about it.
Okay, so it's got out of sight, out of mind. Just keep, like you said, keep it internal.
Yeah, I mean, if you think about any other cloud provider, as we're trying to kind of be, is that as the end user, you don't really care what storage we're using under the hood, right? It should be seamless, and that's the approach that we've taken. It's not going to be going to every customer and go, excuse me, sir, when's a great opportunity to migrate your workload? Because we've got hundreds of thousands of instances that we're working with at the moment. So not overly realistic.
Awesome. Cool. Keep going.
Cool. How does that look for size? Shall I just make that single screen bigger? Let me do that.
Yeah, probably the best way to go. Yeah.
How does that look?
I think it looks good. And folks, just remember, feel free to let us know in the YouTube comments if you want them to zoom in more, but I think we should be good for now.
Cool. I have had feedback that I type very quickly, so
I can just hear it.
I will slow down, but if I'm just scrolling through stuff, just shout and I will happily explain stuff.
Okay.
So what I've got at the moment is I'm connected to one of the superclusters, and I've got a dev node. So it's only for me, but it runs the same stack that we run in production from a software point of view. We're also, as I said, Kubernetes all the way down. So I'm using just some shortcuts here, which is from the ZSH plugin. So KGP, kubectl, get pods. I'll explain these as we go along. What we've got here, if you've not seen KubeVirt before, is every VM is running as a pod, and they're called these Virt launcher pods. You've also got a custom resource called a virtual machine, or VM, which links through to that pod. And you can do operations as you were doing any other IaaS provider. So you can stop, you can start, you can restart instances by using a virtctl command. Virtctl stop. Let's just take this instance, stop. And under the hood, that just terminates the pod that is associated with that instance. So from doing operations like we're going to show, while I'm working with virtual machines, and I'll probably talk about virtual machines, it's the same thing as if we were working with pods. You just need to change the logic of how you do things. So let me just start that up again for the demo. So if we describe this instance, and we'll go through that, it has got some devices attached. So in here, there are disks. There's one called container disk, which is the root disk and contains your operating system. And then there's a second disk for cloud init. So this is the configuration that you provide to the VM. If we get the PVCs underneath that, let me just clear that. We can see that each one of the VMs is backed by an individual PVC. So you've got a VM that's a pod that's then backed by a PVC containing its root disk data. To make all of this easy to work with, we have a custom resource called Civo instance, which again is another way of interacting with that virtual machine, but it gives us more information like the storage class that it's currently assigned to, the size or the flavor that the instance is, and then we've got a private IP, which is on the layer 2 network that's dedicated to the customer. And we've got a public IP. I know these are private IPs, but that again is because it's in my dev node, and they're still routable because I'm on the VPN. If we ran this on one of our public regions, this would come up with a true public IP. So for this demo, let me just SSH into one of these. And what we've got is a fully fledged Ubuntu instance here. So you can do anything you want. As a tenant, you can run sudo and everything that you need to, but it's a VM to all intents and purposes. What I'll do is I will touch a migration file on here. I'll edit that, just say hello DoK. So rather than this now being a vanilla instance that I launched about an hour ago, this is now customized, and users have logged on, they've installed applications, they're just doing everything that they need to do. Alternatively, this is the same demo for a Kubernetes cluster, but rather than it being an instance of Ubuntu, it's an instance that has K3s on it and is running containers itself. If you've ever seen, is it Hitchhiker's Guide? If it's turtles all the way down, for us it's Kubernetes all the way down. Let me exit out of that. And what I want to do now is that process that I outlined here, which is shut down the VM, migrate the data, update the instance spec to point to the new PVC, and then we'll start it up again. So first thing we'll do is stop that instance. And we should see, great, it stopped. Then I have got this manual migration spec. Another layer of extraction in here is this data volume object. What it allows you to specify is a source for the data that is contained within a PVC, and also a storage class for that. So if I create that object, and just clear that again, what that has done is it's created a new PVC with the name of that manual migration. And if I get data volumes, it is currently cloning data from the tenant instance 1 PVC. And that is happening in a pod, which is that one there. So if I just quickly get the logs from that, we should see here, yeah, this is mounted both the tenant instance 01 PVC and the manual migration for tenant instance 01 PVC, and it's copying data from one to the other, which it's now completed doing. So if I get the pods again, those migration pods have finished running and that copy is completed. What I'll do now is if I edit the instance 01 VM, so like any other object, like a pod, you've got the YAML spec for the instance. There are some specs in here, which is the data volume that is assigned to that root disk. So I will manually set that to be manual migration. There is another one. I think that, oh yeah, this is the data volume template. So like you've got with a pod, you've got the PVC that you're mounting and then where you're using it. It's the same thing in here. You've got the volume that you're using and then how you're mounting it inside the VM. So what we'll now do is if we get the data volumes, we'll delete this old data volume because in theory, we don't need it anymore. And demo gods, be kind. So let's get the data volumes again. We now only have the instance 01 that's been migrated. And in theory, if we start instance 01, we have a pod that's creating and it is running, which means that we've not had any errors mounting the new PVC. If we get the Civo instances, we should see as well that it is running and it's maintained that same public IP that we had before. If we SSH to that, in theory, nothing has changed on this. So the uptime should only be a few seconds because we've just started it up. We have a file in here and it's got all of our data in it. If we exit out of that and we get the PVCs, we can see that we've gone from storage class local path to local path migration. Any questions on that process before I move on?
Just real quick, and we don't want to throw Dave under the bus in terms of the code, but to get to this point, were there any surprises along the way of things that you didn't necessarily expect or anticipate?
That's just honestly, I think David kind of said that it was quite simple to get to this point and quite surprisingly simple. So we're using CDI, containerized data importer from KubeVirt.
Okay.
It was initially designed so that you could point it to an HTTP location of an ISO. So, Ubuntu provide daily builds of their like ISOs, so do Debian and CentOS and stuff. So CDI was initially done so you can start a VM, give it an HTTP endpoint of Ubuntu's latest image, it downloads it, and then you can start a VM up from that. And they've added the ability that you can copy a PVC. So as soon as David found that, it was quite a nice surprise for us that it was quote unquote that simple.
It's funny, it seems like the words simple and storage rarely go together, in particular when we're talking about on Kubernetes, but I think that's really refreshing to see that. So shout outs to you, Dave. Good job. And would there be anything that was more complex than you anticipated here, or you would say overall just pleasantly surprised with the level of simplicity you found?
On the actual moving the data, it was quite nice and quite simple. The complexity comes in sort of the next part, well, the working out the process, right? Because actually orchestrating it is more of a challenge sometimes than actually getting the system to migrate the data. Because doing this once, it's taken me, 5-10 minutes to do it, including the migration. Yeah. Scaling that up is the next challenge because we want to make sure that this is not a hands-on job.
Got it. Yeah, David's comment is that it was well documented with a small leap of faith. We got a question. As only David could say. We got a question from someone in the audience. Does it use copy on write behind the scenes?
That is a very good question. I don't think so. I think they are just image files, which are completely block allocated, and then you're relying on the kind of underlying storage provider to not write zeros and do things like the provisioning. So I think it's an option because libvirt would support it. I don't think we're doing it on this.
Okay.
All right.
Crack on.
Let's head back here. So as we kind of covered, running this on thousands and thousands of instances is more of a problem than just doing things manually. Not only is it time consuming, sort of using up a person to do all of that, it's likely if you're doing this lots and lots of times, you're going to make a mistake. It's just human nature. As good as you are, it's going to happen. So operators is the way forward. In Civo, we use operators a lot. The Civo instance object is part of an operator, and that is orchestrating the creation of that instance, the allocation of the network and everything there. So when it came to working out how we automate this, operators were the way forward. The one thing I would always say about operators is they've got this idea of eventual consistency, which I think took a lot of us at Civo a little bit of time to get our heads around. The kind of idea is that you request a state of something, and then an operator promises that at some point in the future, the state you have asked for will be matched, but it won't necessarily be right now. Also, the operator could die or have a problem at any point. So you've got to write your code in a way that will pick up an object in any state and nudge it towards your next desired state and then exit. It's kind of a hard way of thinking and something we've tried to explain quite often, but kind of struggled. So happy to talk more about operators and eventual consistency if questions come up about it. As for the process, very, very similar process on what we were doing, where we're shutting down an instance, doing the migration, starting it up, and then what we're doing to control this is we want to actually now only run this completely automated, but run it with one instance at a time. We're currently controlling this with a label. So we will label the instances that we want the operator to migrate. And then the last thing, rather than remote the migration label, is we need to remove the migration label, which will kind of mark it as this has been migrated. Don't worry about carrying on. So if we swap back over to here, what I've got here is I've got the operator that I can just run locally. I will run this over here. It will spit a load of output, but appreciate it's going to be difficult to see. So I'm just going to hide it, but this is the operator running in the background. So.
And just before we jump too far into this, we got another question. While the migration or during the migration, is it possible to allow volume expansion or later state?
Volume expansion is supported currently, so it probably wouldn't be part of this operator. It would just be a sort of BAU option of just going, right, I've got my instance, let's expand the size. This operator in particular is only responsible for migrating from one storage class to another storage class.
Okay, cool. Thank you.
Right. So all we're going to do is we've got the 4 instances here that are left to migrate. So 2, 3, 4, and 5. And we're going to add a label to them saying migration required, which informs the operator that it needs to work on these instances. So if we apply that, and then now I might need to get 2 terminals up. But if we watch the pods in here, we can see that hands off completely, I'm not doing anything. In the background, the operator is stopping instance 02. It's starting up this migration pod to migrate the data from one to another. It's doing that, and in, I think it's about 30 seconds, we should see it start up instance 02.
Or you're typing with your feet.
Or I'm typing with my feet.
You type fast. You type fast. You type way too fast for just to be your hands.
Let's see what happens. Purposely just waiting.
Hands up.
There we go.
There we
so
go.
that pod has finished. I just keep my hands up here. Do I need to put my feet up as well? It's going to be an odd zoom
we
call.
We need 2 cameras. Yeah, we need a third angle. Anyway, it's all good.
And there we go. We can see the virtual launcher for instance 02 is now running, and the operator's automatically gone on to instance 03. So if we get the data volumes and watch that, we can now kind of just monitor what it's doing with that tenant 03. So we've got, keep my hands up here, we've got that clone happening on that third instance. This gets up to about 35% because it doesn't copy 0 blocks over. And then it will sort of finish that off, and it will delete the old tenant instance 03. So it's come up here on the watch because it's been deleted. It doesn't actually tell you it's been deleted, but if we get the data volumes again, we can see instance 03 has been deleted. The next thing to watch for this instance 04 is that the PVCs under the hood. So we can see 12 seconds ago that the migration PVC has been created for instance 04 on the new storage class. We'll give that 30 seconds or so, and we will see that the old one will get deleted. we go. So yeah, the old one is terminating, and it should go on and create. There we go, pending on the last one to migrate. Let's just sort of watch that instance 05 from a virtual machine point of view. Right, saying it stopped. It will finish the migration and it will automatically start up again. Any questions while we wait? There's a bit of a automation is automation.
No, with the topic of operators is something that comes up again and again and again, to the point that almost probably in every live stream we've been doing, at least the most recent 20 or so, it seems that as of right now that operators are the best solution available in order to work with data on Kubernetes. Do you, as a director of innovation, I imagine you're constantly thinking about, what's going to be coming in 1, 2, 3 years from now. Do you imagine that other kind of solutions will be out there, or deeper integrations that will allow folks to be working with data on Kubernetes apart from operators?
I don't know. I mean, the operator pattern is something that has come out of almost Kubernetes core. That there is the operator for deployments. There's an operator for pods. There's an operator for volumes. I kind of feel that operators have been in the core of Kubernetes almost since the start. And things like operator framework have just abstracted that away and allowed end users to interact with that, and given a nice operator framework, but a pattern for creating custom resources and to interact with them. And once you get your head around it, it's very, very easy to codify operations and repeatable processes. Something I was talking with David about just before this call is kind of like an SRE operator, where this is effectively an SRE operation of you're migrating data, you're making sure things are in the right state. Of wouldn't it be great if for things that you're doing regularly on your clusters, you create an operator that does that for you? And if you needed to, I don't know, like that volume expansion, rather than you being at the console and typing out stop the pod, create a new PVC of the new size, migrate it over, start up a pod, is you create a custom resource in your cluster that is increased pod size or increased PVC size, and you give it your target PVC and your new size. And then you have an operator that understands your application and understands how that works, that will, remove the pod from your whatever load balancer. It will upgrade the volume, migrate it over, do some checks on it, make sure that the data's all valid, start the pod back up, make sure it's handling requests, and then add it back into the load balancer. And codifying stuff like this through the operators is a really interesting place where we are, and kind of opening it out to the industry as a whole to start thinking about how we use operators to codify things like SRE tasks.
I think it's a great point. And also just because not most, companies don't have the luxury of having the amazing team that you have at Civo with so many rock stars, is that it really is, it's a people problem. Like, as much as we can talk about the technical side, there's a huge shortage of people with these kind of profiles, things like operators that allow these tasks to be done in lieu of a person actually being there, I think are definitely going to be important now and for the foreseeable future.
Yeah, I think operators are here to stay, but they're not new. They've been there before. It's just the availability to use operators is new. Right, so that has done. If we kind of check how long that took, so the first one was 5 minutes ago. We started that one up 6 minutes ago, and 3 minutes ago, instance 05 was done. So in the space of, if I can maths, 3 minutes, 4 minutes, the automation has gone through sequentially and migrated 4 instances for us. It's a lot more repeatable task that we can do, and it's less error prone. Come back over here. I mean, this is a process that we are in the middle of. We're currently developing this operator, so we know that we've got more things to add to this. What we'd like to do is have the ability to migrate more than one instance at the same time. We need to add some more awareness to it. So we want to know if all of the instances are part of a cluster, we only want to migrate one of those clustered instances at once. We also want to add more reporting and monitoring so that we'll only move on to the second or third instance in a single cluster. Once that is running, it's registered back into K3s, it's got workload running on it, and all of the workload inside that tenant cluster is running and ready. Because what we don't want to do is just assume because the VM has started that actual end user workload is ready to go. So we want to kind of dig into those clusters and make sure the tenant workload is running before we move on to the next node in that cluster. But we don't want to sequentially do 1,000 instances. We want to sequentially do individual instances in a tenant cluster. The next thing we also want to work on is making sure that we're not overloading that new storage class on the compute nodes ourselves. Because we are in this sort of migration process where potentially only 50% of our data is available on the destination storage class, we want to stop when we've got maybe like 20-30% used, then allow the team to reprovision some of the old NVMe drives because the data's been deleted into the new format. And then as soon as that becomes available, move on and carry on the migration. And the other thing that's really, really key for us is reporting, logging, and monitoring. It means that we can kind of, if we do have incidents and issues, we can work out what has happened when. And this is a fully automated process. It could, start this off on a Monday morning and it finishes on Wednesday. Without logging and monitoring, our SRE team won't know either if something has broken along the way or be able to find out what has happened and then work with the development team on kind of rectifying it going forward. Just a quick shout out to Civo if you don't know about us, aiming to be the fastest Kubernetes provider with quick launch times. At the moment, you can get $250 worth of free credit if you sign up at civo.com. And that was it. So kind of over to any further questions, really.
Yeah, well, definitely. By the way, is Civo hiring? Are you looking for anybody? Or just giving away credit?
We are hiring. I don't know the roles that we've got.
But you are. That's
looking for. Yeah, we are. We're always looking for talented SREs. Go people, marketing. We're kind of growing massively. We've just announced some funding, and yeah, we're looking for people. So if there are good people out there, just get in touch. And generally, even if it doesn't look like we're hiring for a particular role, if you're good, we'll keep in touch and we'll let you know. The other thing to note as well is that we try and hire from our community. David seems to be the star of this show that we're always talking about, but about a year and a half ago, we were looking for someone. David was in the community and he reached out and said, "Hey guys, I really love what you're doing. Do you have a job?" And we kind of got to know him, talking to him, and he joined from our community. And a good few number of our latest employees have been using Civo, been part of the community on our Slack, talking to us, and then we've been like, "Wow, you're amazing. Do you want a job?"
Yeah. Well, I mean, I think it's a very organic, nice way to do it because a traditional sort of hiring process can be quite cold. And if you get to know somebody, through a community-based experience, I think both sides probably know each other a lot better than if it's just a typical sort of process. So anyway, David's saying he was a beta tester.
Yeah,
that's cool. That's cool to see this coming full circle and see his code in your demo. A couple of questions that I do have. The things, we talk a lot in our community about how to run data on Kubernetes, what is running data on Kubernetes, but then more importantly, perhaps in those two questions is why run data on Kubernetes? So like if you're talking to a customer, they're saying, why am I going to bother doing this? I know what you said about some questions that they're just not even going to be on the table. But if they are, if a customer wants to know, what's the value of doing this? Why am I going to do it? How would you respond to that?
Genuinely, I think Kubernetes is the future of the way we're going to be doing computing. If you look back, everyone was racking and stacking their own servers. If you wanted to get on the internet, I'm talking 20 years ago, your only option was to go to PC World, buy a server, start off sticking it in your bedroom, then find out what data centers are, sticking it in a data center, loading OSs on it, Then we moved to virtualization, where we realized, hang on a minute, I've got a rack's worth of equipment and I'm only using 20% of everything. What happens if I can virtualize and get 80% utilization of all my kit? Great. Kubernetes is that next step of virtualization, whereas rather than running VMs, you're slicing almost CPU time down into containers. So kind of a roundabout way of saying is that Kubernetes is the future of all computing, and all computing is reliant on data. So you've got to be able to host data on Kubernetes as a must. And as more developers and more DevOps people move over to being comfortable with Kubernetes, it's a really lovely place to be. You know, I've done that journey. I've been working with racking and stacking servers. I've been there for the introduction of virtualization into a company. I've been in a managed service provider where you're running VMware and KVM, and you're trying to do that. Kubernetes is a much more lovely place to be because it kind of solves that promise of eventual consistency of, I want 3 pods, I want 3 VMs running in this current state. Kubernetes there in the background, and it's got your back of, you wanted 3, there are only 2, I'll start one up. Or you wanted 3, oh, there are 4, I'll just shut one down for you. So that's really nice. But the other thing is it changes the way you host and write applications, because you're writing applications to be in a failure scenario of, rather than assuming that you've got your one server with your WordPress site on it that has to be up if not the business goes down. You put that into a Kubernetes world and you go, oh, I have to assume it's going to fail. And it's just a much nicer place for everyone to be in, because you don't have the business going, why's my WordPress site gone offline? It's like, oh, WordPress failed, but the second replica just took over all of the load, and 20 seconds later, it was back up to full resiliency, and I'm still asleep in bed and I didn't know about it.
Wow, that's very well synthesized. And particularly with the last point that you were mentioning, because we've had different folks on here talking about SRE principles, and when we talk about SLOs, SLAs, SLIs, is like an assumed part of this is going to be failure, and that's okay. But like you said, is that's why you have then replicas to keep things going if there is a problem, but just building that into your model of understanding this is going to be part of it, but we're going to be prepared for it by having a proper plan in place. A couple of other questions. If you had a magic wand, because we were talking about simplicity earlier, excuse me. If you had a magic wand, what would you do to make running data on Kubernetes easier? I guess just getting David involved in every project?
I mean, yeah, that's perfect. If you've got a cloning machine, we can just clone. I mean, perfectly. Clone me, and I'll be on the beach while this version of me is here. That would be ideal. That'd be nice and simple. But I think the issue has been with data on Kubernetes is that data hasn't been designed for failure, right? You go back to what I was saying about WordPress is there is a single MySQL database behind it, and things like that haven't been designed for either a clustered workload where something is going to fail. So that has always been the challenge of data. Actually writing data in a Kubernetes environment is not difficult. It's a kind of solved problem. You've got some block storage, you write data to it. The problem is always at the application level, that things like MySQL or Postgres or even WordPress with your upload directory, it's assuming that there is one upload directory that is always online. And that's the biggest challenge of moving data to Kubernetes, is finding applications and writing applications that expect failure at a data level.
Mm-hmm. Good. Question from the audience. What are the chances of the migration failure cases?
So with the way that the operator's written is that if there's a problem with that migration and it fails to copy data over, the VM won't start, and then it won't delete the old PV. So the operator is written so that it will go, oh, VM hasn't started. Let me just reattach the old PV. We'll start the VM up, get the customer running, and then we'll work out how we go back and fix it. And that's more of a manual process of that reporting and logging thing of like, I have failed. The operator isn't going to be intelligent enough to work out why it has failed. All it's going to do is fail safe, fail happy, get the customer and the VM up and running, and let future David sort out that failure.
The future, we see David in it solving that.
Exactly.
No, that looks good. Okay, one last question before we wrap it up. Something that this is actually the first time we're doing this, so lucky you as you work in innovation. But something just a nice touch is to try to get a little bit more knowledge about you as a person, things you like to do, etc. So what I want to ask is, if you could run data on Kubernetes with a single person, superhero, historical figure, musician, actor, doesn't matter, who would it be and why?
Oh, that's a really good question. I mean, weirdly, the first person that came to mind was Jean-Luc Picard from Star Trek, which, you know, he just seems like he's always, either if he doesn't have the right answer straight away and makes a mistake, probably the thing about Picard is he's got a team around him that kind of steers him back in the right direction. So maybe if I expand that to the enterprise, if I could run data on Kubernetes with the enterprise crew, that would be awesome.
No, but that's cool. I like that. I think that's also, once again, is that we had a wonderful live stream with the guy. Oh gosh, what was his name? I'm trying to forget now. Oh yeah, Salman Iqbal, who's also in the UK, about backup and restore. And he's like, do not treat Kubernetes just as a technical problem. You have to make it a people opportunity. And so that's what you said, is that even if you don't have the right answer, if you have that solid team with you, then, and you very much do, obviously in Civo, you're in great hands. That's a lovely answer. So good job being the first person to have to do that. We got one more question. We got one more question.
Yeah, go ahead.
But so any session in use related failure?
Can you repeat that? Any session?
Sorry, yeah, this is all that's written. These questions are very good in brevity and not necessarily strong on depth. It says, are there any sessions in use related failure? Talking about the migration failure cases.
I'm not entirely sure I understand the question. So
that's okay. No, don't worry. Well, this person is always in our live stream, so we'll just invite him to continue the conversation on Slack. So you can feel free to share the question there. Last but not least, let me just, I got to share my screen really quickly, because while you're talking, we also have a tradition where in the middle, throughout the course of our live stream, something else is happening in the background. And that is our amazing, let me know when you can see my screen. Yeah. So this is our amazing graphic recorder, Angel. So it put together this drawing of all the different things that were mentioned, and was able to include David as well. So that's very important. David there on the right. So all the different things that we were being mentioned as talking about this issue of, migrating storage from one vendor to another. Really, really good stuff. Dinesh, it was a pleasure having you. If people want to find you, because you're a little bit more secretive, more difficult to find than some of your Civo counterparts, but what's the best way to reach out?
Best place sadly is on the Civo Slack.
That's
me
fine.
on there
That's okay. Yeah,
because it's kind of just where I am all the time, because I kind of live and breathe Civo. So that's where you find me, and feel free to reach out there.
Yeah, feel free to reach out. Seriously, they've got a rock star team of amazing people there. Can't speak highly of them, too highly of them. Looking forward to having more folks from Civo on future live streams. I really like that Star Trek reference. That's a great way to finish. I love that. That's super good. That's going to be tough to beat. So you can definitely be sure to see some of that stuff in the follow-up. Dinesh, thank you very much. It was a pleasure having you. Thanks to everyone in the audience. If you want to continue the conversation, jump in our Slack or get into Civo Slack. Get those questions answered directly. Take care, man.
Thanks, everyone. Bye.